Alright, so, excuse my voice, I'm a little bit sick right now. Let's say you've got a block box sliding down a hill, okay, mass M. And I'll have it sliding constant acceleration, okay? So that's my velocity, and that's my acceleration. And my acceleration is constant, so it's not changing, okay? And start with a force diagram, okay? There's weight downward. And also I'll put an angle, any angle we want, theta. Okay, so we got weight going down. We've got normal force kind of at an angle, right? And you'll notice that I'm going to say that there's friction. So there's a mu k. So for given, we have mass, we have mu, we have gravity field G, strength of our gravity field. And I'll also say that our object starts from rest, right? V naught, I'll say, is 0. Okay? So the surface has friction, so I'm going to need to draw that. That's kinetic friction because the block is sliding. Okay? Now I'll draw some reference lines, identify my angles. There we go. There's an ant on my iPad. There we go. Oh, one more. There we go. Okay. And let's see here. Okay, so let's find out where theta is. So if I zoom in on my picture, my angle theta is this one, right? Which means my angle theta is here too. And my normal force is going to tilt from vertical the same amount my surface is tilted from horizontal. So that's something you have to imagine in your mind. When a surface gets tilted, normal force is perpendicular to that surface. So if the surface gets tilted a certain amount, the normal force gets tilted the same amount, but from vertical. And then these two are opposite. So you'll see this familiar pattern where you got every other angle being that angle theta. Now I'm going to draw a vector sum diagram. I'm going to add the vectors. But I'm going to make sure that my vectors don't add to 0. They should add to an acceleration that's in the proper direction. So there's normal, right? Now I'll add weight. I'm going to make normal longer. Then I'm going to add weight down, straight down. Okay. I don't like that one. I'm going to draw that again. I'm going to add normal straight down. Something like that. That might be a little too far. Let me fix that. There we go. Because remember, my force vectors have to add to a net force that points in the same direction as my acceleration. So you have to keep that in mind while you're doing this. So this is mg, this is normal, and then friction is like, let's see, friction is up the hill, so friction's going like that, right? That looks parallel to my surface. This can be a little longer, and that's mu k normal, right? And then my net force vector will be this way, right? That's the three forces normal mg and mu k normal added together, and that will be equal to ma, right? So at this point, you'll want to find where the angle lies on your vector sum diagram. right? We know that this is a right angle there. I've done so many reference lines on my force diagram, it's like really easy to see that this angle here is my angle, which is the same as this angle here, right? So if you do a good job on your force diagram, it's pretty easy. And at this point, I'll just use sine and cosine, right? So maybe I'll use sine, I'll use cosine over here. Cosine theta, that's going to be the easier one in this case. Cosine is normal, sorry, not normal. Yeah, cosine is normal over mg, right? And so that means normal is going to be mg cosine theta. And then using sine, I'm looking at my opposite side, which is mu k normal plus ma, right? And so that means ma equals sine theta minus mu k normal. And so a is going to equal sine theta minus mu k normal. And that's all over mass, right? Make sure I didn't forget anything here. Did I forget anything? Yes, I totally forgot something. This is all over mg right here, right? So there's an mg actually. Let me repair this right now. Equals mg sine theta minus mu k normal. Now we're good. And then I'll fix the next step as well. Right? So what I have is a equals mg sine theta, and I'll extend this a little bit. Right? Now I can plug this in here for normal force. Right? So then a acceleration is going to, the magnitude of our acceleration is going to be mg sine theta minus mu mg cosine theta. And that's all going to be over m. And then so acceleration, everything's divided by m, so I can eliminate m from every term because m is in every term. So what I have is g sine theta minus mu g cosine theta, right? And I can factor out g, and then I have sine theta minus mu cosine theta. So what I've got there is the acceleration of a block, object, sliding down a hill with friction. I encourage you now to just find, given a mu, right? This is mu k in this case. I should put a little k there. Given a coefficient of kinetic friction, could you find the angle at which something slides in terms of the other variables? That would be a useful activity. Again, you should be able to figure out at what angle a block would start to slide down a hill given a mu, given a coefficient of friction. Anyway, I hope this helps, and thanks for watching. Have a good day.